students, in the previous video session you have gone through Newton's first law and the types of inertia based on the circumstances. In that you have gone through the inertia of rest, inertia of motion, inertia of direction and inertia of motion. So different types of inertia and all you have gone through in the last video. Today let us discuss about this Newton's second law. And before going through this Newton's second law, you can go through a small part. Here some example given on your textbook on page number 108 about the inertial frame, which is already discussed about this inertial frame and frame of reference in the part 2.2 unit 2.2. We have discussed this frame of reference. So you have watched in the previous video about the frame of reference, and here also saying about this inertial frame. And we know that what is the use of this we are seeing means assume that there is an object is kept, so we can analyze the motion of the object, whether it is kept at rest or it is in motion. We can find out by using a frame. So that is what we have seen that in that you can see that here it is saying about the inertial frame and the non-inertial frame. So all these inertial frame we are considering a frame. What we can say means if you are seeing example, assume that you are traveling in a train. So when you are traveling in the train, sometimes we know that long travel and all, we know that they will keep the train to allow the other train, fast passenger train and all can move. For that they will stop the train somewhere. So we know that sometimes we are staying in the train and our train is at rest, that we don't know, or you can tell that your train is stopped somewhere in a station. Okay, so next by you another track, you can see another train is there, and suddenly you have seen that you feel that your train is moving. Maybe we all have that experience. Okay, we are sitting on the train and it is stopped in a station. So another track nearby our track, we can see that another train is there. Suddenly we will feel that our train is moving. So but when we are looking outside the earth, the ground we are looking, what we can see is our train is not moving. The train which is staying near stopping our another track, that train is moving. Maybe you have this experience. So we are finding that movement or the motion of that train by seeing the platform or the ground. So that is what we can tell that this is what we are considering the motion of the train by using an inertial frame, and I have considered that platform as a inertial frame. I am using a frame, so I am using that earth or that ground or that the platform or the train, railway station, I have used as the inertial frame. So like that we can tell that in textbook many things are given, so just you have to understand what is this about this inertial frame, that muchly. So by using this concept inertial frame, we can analyze the Newton's first law and the second law. And by analyzing the Newton's first law, we know that Newton's first law, every object continue in its state of rest of uniform motion. So when we are analyzing this law for the far object, or you can tell that the object which is in the space, what Newton said, it is valid when we are analyzing by using this inertial frame. For example, assume that we are standing on the earth, or sometimes we know that we are standing on the earth. While we are standing on the earth, we have seen that an aeroplane on the sky. So while seeing the aeroplane on the sky, we are trying to locate the position of that aeroplane, but the correct location where it is, we cannot analyze the position, because the flight is moving, the aeroplane is moving, but when we are looking this aeroplane from the earth, from our place, what we can see is it is at a rest. Maybe you have the experience of this, no? Maybe everyone have the experience of this. Staying on the ground and looking the aeroplane on the sky, we feel that why it is not moving. Sometimes we used to tell that why it is not moving. Like that we can feel. That is what Newton's first law is valid. Only if you are looking through this inertial frame, this Newton's first law will be certainly valid. Such deep space can be treated as inertial frame. So for this type of object and all, we can use a inertial frame to analyze this motion is little difficult. That is what you can tell that maybe you have understand about what I said, this inertial frame and all. So another you can tell that but the thing is the flight is moving and it is not at rest. While we are staying here and looking that, we are feeling like that, but it is not possible, no. Practically it is not possible to reach such deep space and verifying the Newton's first law. So that is the thing. So for the very far object, considering like this inertial frame and all, little practically it is difficult for us. For that what we are doing means practical purpose and all, we are using our laboratory, and in that laboratory we are considering our earth as an inertial frame. For example, if you are saying that, assume that you are inside a physics laboratory and in front of you table you can see some of the object. Actually, whether this object in front of you on the laboratory experiencing any force? Is that experiencing any force? Actually, it is experiencing a force. It is experiencing a force means when an object is at rest on a table in front of you on the laboratory, if it is rest also, there is some force acting on it, but the force is only on this vertical direction. You know that always there is a gravitational forcing acting on that object. To balancing that gravitational force, there must be an upward force is also acting, and this we can analyze by using inertial frame. You know that if you are looking that there won't be any by using our naked eye, we know that there is no force acting on it. We will not feel that there is no forcing on it, because when we are looking the object, it is at rest, it is not moving anywhere. So it is not showing horizontal motion. Just a vertical motion is there. That is what a gravitational force which is acting downward on that object, and to balance that there is an upward force acting. So if you are looking the object, there is no horizontal force acting on that object. So that is what so now we are analyzing this object motion with respect to the ground. So like that, assume that you are inside the train. Sometimes we know that suppose you are inside the train and that the train is moving with a constant velocity while considering a inertial frame. For example, you are sitting inside the train and we will look outside. So we will consider our outside as the inertial frame, and but you are staying at rest inside the train, no. So outside the object is at rest, we are considering as the inertial frame. Outside we can see that while traveling in the train, nearby the window side we will sit and we will look outside. We can see that all the object is moving, but the train is moving. So that other outside object is at rest only. So that we are considering as a inertial frame. Now For that object, we are considering what? Our train as the inertial frame. So, like that, to analyze the motion, whether it is at a moving or at a rest, we are considering what? We are considering an inertial frame. So, this example is a very good example when you are traveling in the train, no, sitting inside and traveling. So you feel that all the object which is outside of your train, trees, everything is moving. So when you are considering your train as an inertial frame, you know that that object is at a rest. Like that, you are sitting inside a train and traveling. One person who is staying outside, he will feel that you are moving. He will feel that you are sitting and you are in motion. But when he consider your motion with respect to the train as an inertial frame, he know that you are at a rest. So this is what about the inertial frame, and this is enough. Not more example here. Textbook many things given. So actually it is no need. And this is what we are saying inertial frame, and all the rotating object. All the rotating object, or you can tell that accelerated frames, that is non-inertial frame, or you can tell that a rotating frame also a non-inertial frame. So like that, just go through that, and based on these, after this inertial frame, you can see Newton's second law. It is a very, very important law, Newton's second law. We know that Newton's second law, F is equal to ma. This is what from our childhood we are learning. Actually, this formula is derived. F is equal to ma is derived from F is equal to dp by dt. This is what Newton's second law. Very, very important formula. F is equal to dp by dt. This is Newton's second law. This is Newton's second law means the force acting on an object is equal to the rate of change of its momentum. So what does this mean? Whenever the momentum of the body changes, there must be a force acting on it. That is what Newton's second law he is saying. If you are saying about this momentum, already we have discussed in the second unit. Whenever there is a momentum means we know that P is equal to M into V, mass into velocity. So whenever there is a change in momentum, there must be some force acting on it. So if you are applying this P is equal to mv on this equation, we will get F is equal to d by dt of mv. So from this you can write an equation F is equal to dv by dt. This m you can take it outside. So we know that with dv by dt means what? F is equal to m into a. What is this a? Acceleration. So acceleration is equal to dv by dt, change in velocity by time. This is what Newton's second law. The force acting on an object is equal to the rate of change of its momentum. The force acting on an object is equal to the rate of change of its momentum. This is one of the very, very important 2 mark, 3 mark question. Many times it is asked. Next, you can see some of the one definition for 1 Newton. What is 1 Newton? 1 Newton means we know that 1 kilogram of mass to give an acceleration of 1 meter per second square. So 1 kilogram of mass of a body giving an acceleration of 1 meter per second square. That is what we are saying 1 Newton. So 1 Newton means 1 Newton we can define. It is we know that the Newton's second law, F is equal to ma, and the force unit also, which is described by using this Newton's second law only. You know the unit of force Newton. Unit of force is Newton, and we are using the symbol N. And you can define this Newton. What? How you can define? How much mass? 1 kilogram of mass. You have assume that you have a mass of 1 kg, and that mass, how much acceleration? That mass can give an acceleration of 1 meter per second square. That is what? 1 Newton. So 1 Newton is defined as the force which act on 1 kilogram of mass to give an acceleration. So what is 1 Newton means what? A force which act on. Suppose assume that you have a 1 kilogram of mass object in front of you. Assume that this book. Now this book is having 1 kilogram, and you are applying a force on this book. Now this book, 1 kilogram of book moves what? With an acceleration of 1 meter per second square because of the force you applied. That is what 1 Newton we can tell. So again I will tell, if you want the example. Assume that you have in front of you your textbook. Assume that this is 1 kilogram. Now I am applying a force on this. When I am applying a force on this, what? This 1 kilogram of this object moving with an acceleration of 1 meter per second square. That is what we are saying. What? 1 Newton. And these two things you can study. Here Newton's second law is very important, and go through the definition of 1 Newton. And after this you can see there is an approach. Aristotle words Newton's approach. Aristotle said something 2500 years ago, and Newton is finding. What is that we can see? Newton's law gives a correct explanation for the experiment on the inclined plane. That was actually we have discussed. We have go through last video session. You have gone through this inclined plane experiment, isn't it? This inclined plane experiment. Aristotle said that what Aristotle said. Aristotle said that no force is needed for motion. Sorry. So Aristotle said that there is a force causes motion, and Galileo said that what? Force no need for the motion. But Newton is from Newton's second law, he is proving that that inclined plane experiment. They are not telling about the frictional force. There will be a frictional force. That is what Aristotle, he didn't mention about the word frictional force. But he said some force causes motion. And through that Galileo experiment, he forgot to prove that thing also. If you are seeing that experiment, we know that in that last diagram here, in this experiment, here you can see that everywhere the ball dropped from here, and you can see that when it reaches some position, this ball stops. This ball stops. You have to note this point, the ball stops. And in this last experiment also, you know that it moves on the smooth surface, and it moves more distance. Then it is what? Then the ball stops. How the ball stops? There is a reason. The ball stops due to the force. What force? Yeah, the frictional force. There must be a frictional force which is acting opposite to the movement of the ball direction. That's what that ball stop. So what Aristotle said, the force causes motion, isn't it? So here as per Aristotle idea, as soon as the body reaches the bottom of the plane, It travel only certain distance and stops because there is no force on it on the object. He did not completely explain. He did not consider this frictional force also. This is proved by, this is told by Newton's, after this Newton's second law. So you can go through this just an idea. And the next part is Newton's third law. We know that from our small grade we are studying to every action there is an equal and opposite reaction. That is what Newton's third law. So Newton's third law means what? For every action there is an equal and opposite reaction. Very, very important third law. Newton's third law states that for every action there is an equal and opposite reaction. So what is Newton's first law? I will tell something about the Newton's third law. So Newton's first law is every object continues to be in the state of rest of uniform motion unless there is an external force acting on it. Newton's second law, the force acting on an object is equal to the rate of change of its momentum. F is equal to dp by dt. And Newton's third law is to every action, for every action there is an equal and opposite reaction. If you are saying about the action and the reaction, we know that if you are throwing a ball on the wall, the same speed that ball will come back. So for the action there is a reaction. And we know that striking the hammer on a wood, when you are striking this nail on this wood by using the hammer, we know that how much hard we are hitting on this nail, you will feel an backward force. We will feel a force on our hand also. That is what? A backward reaction. How much force we are hitting hardly, we will get the pain on our hand. We will get the pain on our hand. That is the reaction. Here also you can see that a ball is thrown on this wall and it is coming back. That is what? Action and reactions. For every reaction there is a reaction. And here you can see that walking time. Actually while walking we know that walking or playing, how much force we are pushing the ground, and we are pushing the ground backward and we are going forward. While walking, we have to think about this. While walking, what you are doing? We are pushing the ground backward. But that is the action. Pushing the ground backward is the action, and the reaction is what? We are moving forward. So you see how nice law which is given by Newton's. So Newton's third law is what? For every action there is an equal and opposite reaction. So my dear students, you have to study this. This is your study. Take it as a study portion. Newton's first law, Newton's second law, Newton's third law. These three laws completely study. There must be a question from this, 2 mark or 3 mark question from this, out of these three laws. So thank you all. See you.